Hello, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Mechanical Engineering. This is a lab manual in Unit 8. Section 1, Forces and Motion. Gold medal in bobsledding. Vanetta Flowers used to dream of competing in the Summer Olympics in track and field. In 2000, she tried out for the Olympic trials but didn't earn a spot on the team. She felt discouraged and thought about giving up on her Olympic dreams. 2 days after the Olympic trials, Vanetta's husband saw a flyer urging track and field athletes to try out for the U.S. bobsled team. Vanetta didn't know much about bobsledding, but her husband, also a track and field athlete, convinced her to try out with him. She did, and 1 year later, Vanetta won a gold medal at the 2002 Winter Olympics. In the two-person bobsledding event, with her gold medal, Vanetta broke several records. She was the first person from Alabama to win a gold medal in the Winter Olympics, and the first person of African descent from any country to win a gold medal in the Winter Olympics. The initial push. In bobsledding, a 2 or 4-person team drives a specially designed sled down an ice track. In the first 5 seconds of the course, the bobsledders sprint while pushing the sled forward. They push with as much force as they can to get the sled moving. They then jump into the back of the sled behind the driver to move down the track. They can reach speeds of up to 135 kilometers or 80 miles an hour. Bobsled energy system. The initial push is a key part of a successful bobsled run. This is the only chance the bobsledders have to apply force to the sled. This is important because forces transfer energy into or out of energy systems. An energy system is a set of connected parts that change an input of energy to a different output of energy. Look at the picture on the right. It shows Vanetta and her teammate Jill Bakken at the beginning of the Olympic race. Vanetta, Jill, and their bobsled form an energy system. At the top of the hill, the bobsledders have gravitational potential energy, which is the energy stored in an object as a result of its vertical position or height. The height of the hill causes the amount of energy stored in the bobsledding energy system to change. The higher above the ground they are, the more gravitational energy they have. But the sled needs a force to get it to move in the beginning. This is because of the law of inertia, which states that an object at rest will remain at rest and an object in motion will remain in motion unless acted upon by an outside force. When the bobsledders push the sled, they provide the outside force that changes their motion. The force of their pushing transfers kinetic energy to the sled, which begins to move because it now also has kinetic energy. Increasing force to increase speed. The more force the bobsledders apply to the sled in the beginning, the more speed they will have on the rest of the track. Because of this, bobsledders need to be very strong. This is why there was a flyer urging track and field athletes to try out for the U.S. bobsled team. These athletes have tremendous speed and power they can use to push the bobsled. Here's a picture of Vanetta Flowers. And here is Vanetta Flowers and Jill Bakken. Forces and interactions. Once the bobsled begins to move over the track, the force of gravity takes over. Remember that gravity is the attractive pull between all matter. Earth's gravity pulls down on all objects, including the bobsled, as it moves over the hill. As they begin to move down the hill, the primary goal of the bobsledders is to reduce the forces that act on them that might slow them down. This is because forces can transfer energy out of a system as well. The bobsled is carefully designed to minimize the forces that transfer energy out of the system. Forces that transfer energy out of a system. Friction is one way that energy is transferred out of a system. Friction is a force that slows motion when two objects rub against each other. Friction slows motion because it causes some of the energy of the moving object to change into heat. Friction is why your hands feel hot after you rub them together. Ice is much smoother than other surfaces, so there is less friction that occurs, when the sled moves over the ice compared to rougher surfaces such as grass. The amount of friction explains why it is difficult to walk across ice without slipping and falling. However, some friction still occurs. To counter this, fast bobsleds are made with smooth runners that are as thin as possible. This is to reduce the amount of surface area that comes into contact with the ice, and therefore reduce the amount of friction. Drag, also called air resistance, is another force that transfers energy out of a system. Drag is similar to friction, but it occurs between a solid substance and a fluid, such as air. Air moving around the bobsled produces drag, which transfers energy out of the system. The shape of the bobsled and the materials it is made from are designed to reduce the amount of drag. The bobsledders themselves also wear skin-tight clothing to reduce drag. Relationship between forces and mass. There are rules about how much mass a bobsled can have when empty and when the bobsledders are on it. Remember that mass is the amount of matter in an object. An object's motion will change according to its mass, as well as the sum of the forces acting on it. This is because of another law of motion, which states that force equals mass times acceleration. Acceleration is an increase in speed over time. It is measured in meters per second squared. This law says that the amount of force needed to move an object any distance depends on its mass. An object with greater mass needs more force to accelerate than an object with less mass. In other words, a more massive sled will need more force to cause it to accelerate a certain amount than a less massive sled would need. A moving sled. Once the sled starts moving down the hill, a more massive sled will go faster than a less massive sled. We'll explore this idea more in the next section because it has to do with the relationship between an object's mass and the amount of kinetic energy it has. Beginning in 1952, the Olympics Committee established rules for how much a sled could weigh when it was empty and when the bobsledders were on it. Before 1952, bobsledders tended to be big and heavy. After 1952, the emphasis changed. It became important for bobsledders to be strong enough to push the sled with a lot of force, but light enough to meet the weight requirements. More massive sleds need more force to accelerate than less massive sleds. Section 2, Energy, Speed, and Mass. Race car driving. When the black and white checkered flag is waved on a racetrack, it means one thing: the race is over. A plain white flag means drivers have one more lap to go, and a green means go. There are 8 flags in stock car racing. Each flag has a specific meaning for the drivers. An easy visual way to communicate with the drivers is important because they can reach speeds of 322 kilometers or 200 miles per hour. Speed is the rate at which an object covers distance in a period of time. It refers to how fast an object is moving. Speed is a ratio. It is calculated by dividing the distance traveled by the time spent traveling. It is measured in meters per second. Speed is closely related to velocity, which is the rate at which an object changes its position in a specific direction. Energy conversions in a car. Race cars are built with powerful engines to increase force and acceleration, and increase in speed over time. Engines are important because they convert inputs of chemical potential energy stored in gasoline into outputs of kinetic energy that move the car and heat. The average racing engine can push a car with a force of 750 horses. Relationship between energy, mass, and speed. There are many rules in car racing. This is to create an even playing field for all drivers and to keep the drivers safe. Safety is important because the cars move at such high speeds. The faster the car is moving, the more kinetic energy it has. This is why collisions are more dangerous at high speeds compared to low speeds. The speed of an object is proportional to the amount of kinetic energy it has. It is a non-linear relationship that changes exponentially. In an exponential relationship, the rate of change increases exponentially each period. When the speed of an object doubles, the kinetic energy quadruples. When the speed of an object halves, the kinetic energy decreases by a factor of 4. We can visualize what this looks like in a graph. The graph below shows that the relationship between an object's speed and the amount of kinetic energy it has is a non-linear proportional relationship that changes exponentially. To help keep drivers safe, there are rules about how much mass a race car can have, just like in bobsledding. Race car drivers pay close attention to the mass of their cars. They know that more force is needed to cause massive objects to accelerate the same amount as less massive objects. Remember that a force is needed to transfer energy into a system, and the larger the force that is applied, the more energy is transferred into the system. There is also a proportional relationship between the amount of kinetic energy a moving object has and its mass. The more mass a moving object has, the more kinetic energy it has. Think of a pebble sitting on top of a hill. To get the pebble moving down the hill, you need to apply a force to it, such as by kicking or throwing the pebble. However, because the pebble doesn't have much mass, it doesn't require a lot of force to move it. A boulder is different. You would have to push it with a lot of more force to get it to move because it is so much more massive than the pebble. Now picture the pebble and the boulder both moving down the hill at the same speed. The boulder has more kinetic energy than the pebble does because the boulder is more massive. This is another proportional relationship. If the mass of an object doubles, its kinetic energy also doubles. If an object's mass decreases by half, its kinetic energy also decreases by half. We can visualize what this looks like in a graph. The graph to the right shows that the relationship between a moving object's mass and its kinetic energy is a linear proportional relationship. In a linear proportional relationship, two quantities vary directly with one another. If one quantity is doubled, the other related quantity is also doubled. Section 3. Solving mechanical problems. Delivering mail in Alaska. In southwestern Alaska, transportation is difficult. There aren't many roads connecting the small towns and villages to one another. This makes mail delivery challenging, especially in the winter when it is too dangerous to fly planes. In response, the U.S. Postal Service began using a hovercraft to deliver mail in the late 1990s. A hovercraft is a vehicle that travels over land and water on a cushion of air. A vehicle is a machine that moves passengers or goods from one place to another. Bobsleds and race cars are also kinds of vehicles. The hovercraft in Alaska carries mail year-round, except for 6 weeks when the water is just beginning to freeze, and 1 week when the ice begins to melt in the spring. This is because the hovercraft needs a relatively flat surface to hover above. This search and rescue team practices a rescue using a hovercraft. Engineering a hovercraft. A mechanical engineer named Christopher Cockerell was the first person to create a hovercraft. He used cat food cans and an air blower. He continued to test and revise his idea, crafting miniature hovercrafts out of balsa wood and fans. Mechanical engineering is the field of engineering concerned with applying forces and energy transfer to design and build machines. Mechanical engineers focus on using machines to solve problems. A machine is a technology that uses kinetic energy to do work. A hovercraft works because of how it applies forces to move. It must create force, a push or a pull, to move forward and lift off the ground. It does this with large fans located beneath the hovercraft and on the back of the hovercraft. These fans push the vehicle forward. The fans are powered by a motor that transforms electrical energy into kinetic energy. When the motor is attached to a power source, such as a battery, the motor spins. That spinning is what powers the fans. The fans force air down through a hole in the base of the vehicle. The air from the fans is contained by a skirt made from a flexible strip of rubber along the base of the hovercraft. As the skirt fills up with air, pressure builds and some air escapes around the edge of the skirt. The force of air pushing down from the top of the hovercraft and escaping along the edges of the skirt causes the hovercraft to lift above the surface. The escaping air separates the skirt from the friction of the ground surface. The airflow within a hovercraft must be balanced to prevent the vehicle from tipping from side to side. A hovercraft has different parts to support the vehicle so it functions properly. Transportation subsystems. Every vehicle is a system because it is made up of connected, interacting parts. Each vehicle is also made up of smaller subsystems that allow them to function properly. The key subsystems are a propulsion system, a suspension system, a control system, a guidance system, a structural system, and a support system. Take a hovercraft. A mechanical engineer has to balance 4 forces to achieve movement. Thrust is what makes the hovercraft move forward. Thrust is generated by the propulsion system, which provides the force that moves a vehicle toward its destination. Thrust must equal or exceed drag caused by air resistance between air molecules and the hovercraft for the vehicle to hover. Lift is what causes the hovercraft to move upward. Lift must oppose the hovercraft's weight, which is how much the force of gravity pulls on it. The basic framework of a hovercraft is designed to provide structural support. This is called its structural system. Once the hovercraft is in the air, the pilot needs a way to control its speed and path. The control system sets the speed and direction, while the guidance system provides information about the vehicle. As the hovercraft moves, it relies on its suspension system. The suspension system provides for a smooth ride by absorbing the external forces that act on the hovercraft. When the hovercraft isn't being used, it is maintained through its support system to ensure that all of the parts and systems are working as they should. While all vehicles are made up of the 6 subsystems, they are designed differently depending on whether they are intended for land, water, or air. For example, vehicles intended for land include cars, trucks, buses, and trains. They are propelled forward by engines supported by fossil fuels or electrical stations. Tires and shocks support the weight of the vehicle as they move across the road. Road vehicles are typically controlled by steering wheels. Vehicles intended for the water include boats, canoes, and warships. They can be propelled by human power, such as oars, wind power with sails, or mechanical power with engines. The weight of a boat is suspended by buoyancy. Ships today use advanced navigation equipment that can determine the ship's location, how close it is to the land, how fast it is going, and possible underwater hazards. Vehicles intended for the air include planes, helicopters, and jets. They are propelled forward by the action-reaction forces of turbines or the spin of propellers. The weight of an airplane is supported by the wings, which are kept airborne by lift. Airplanes also have advanced navigation equipment that helps pilots determine their location, height, and speed. Air traffic controllers act as an additional airport guidance system. A truck is a land vehicle. A sailboat is a water vehicle. A helicopter is an air vehicle. I learned a lot reading mechanical engineering, and I hope that you did too. I'll see you tomorrow with another one. Bye.